there, in this video we're going to take a look at a special case where we are trying to integrate powers of trig functions or trig functions where our angles happen to be different. So in the previous videos for this section for our Calc 2 class, all of our angles have been the same, or we're able to use a double angle identity or something like that to make the angles the same, but we're not able to just say something, for example, like u equals sine of 4x. Well, if that's the case, my du would be 4 cosine of 4x dx. And what you'll notice is the trig function is correct for what I have in my integrand, but the angle is not. So in your trig or pre-calc class, hopefully you saw these sum to product or product to sum formulas. And what these identities do is they take a product, for example, a sine of A cosine of B, where my angles are different, and it's going to turn it into a sum of two trigonometric functions, one where you have the difference of the angle and one where you have the sum of the angle. So this is exactly the identity that we're going to want to use here so that we're able to integrate this. So I'm going to say that this is sine of A, which A will be 4x, and cosine of B, so my B will be 5x. And I'm literally just going to fill in what this identity tells me that it will be. So this should be the same thing as the antiderivative, right? This isn't calculating the antiderivative for me. This is just going to rewrite my integrand, make it hopefully easier to integrate. So I'll have a half as my coefficient, and then I have sine of A minus B, so it'll be 4x minus 5x. And that should be added to the sine of A plus B, so 4x plus 5x. And of course, this is all still integrated with respect to x. So I'll subtract these. I could pull the half out front if I wanted to as well. And I'll add these angles, 4x and 5x give me 9x. And I absolutely should be able to integrate this at this point. So I'll show you two different schools of thought here on integrating this. One of which is that this sine of negative x is what's called an odd function, which means that the negative can come out front because it is symmetric about the origin. So I could say that by definition, this first antiderivative will be a negative 1/2 sine of x dx, and then I'll distribute that half. The second integral will be sine of 9x with respect to x. And I should be able to integrate these now. So the antiderivative of sine will be a negative cosine, which will turn that negative half into positive a half. And then again, the antiderivative of sine of 9x will be a negative cosine of 9x divided by a factor of 9, which will make this 1/18. And don't forget your plus c. Okay, so you might be thinking, gosh, I don't know if I'd ever remember that sine was that odd function. Okay, you don't have to remember that because it will figure itself out for you. So let me show you what I mean. Okay, I rewrote the problem just so we can do it a different way here. So I can just look at this almost like a U substitution, right? Or a chain rule type of thing. So if you were doing the derivative of sine of negative x, right, you would get cosine of negative x, and then you would have to multiply by a negative 1, right, for that chain rule. Or in your U substitution, u is negative x, so du is negative dx. So I can put a negative out front, and then the antiderivative of sine of an angle is negative, so this will turn that 1/2 positive, cosine of the angle. And then I do the same thing that we did over here with the sine of 9x. It will be a cosine of 9x, because you're not allowed to change that angle. And then divided by another 9, and I'm going to change that in between sine to a minus, because I need that negative in there, plus c. And you might be thinking, gosh, these aren't the same. Well, these are actually equivalent because cosine, if you remember, is an even function. So a half cosine of negative x is the same thing as a half cosine of positive x. So those answers are equivalent. So I hope you found this quick video on special cases of integrating trig functions where our angles are different helpful. Thanks so much for watching.